Hey everybody, Mr. Covey here, and I'm going to go over the polynomial mini quiz form B here, and I'm going to go through the questions in order, so if you want to skip ahead to certain questions, that's totally cool. So first question here says if you fully factor this expression, you're supposed to get something that looks like this. What is the Q, the P, and the C when it factors and looks like this? So first thing you need to do here is take out a GCF. That's always what you do first with factoring. What do all those have in common? They all have a 3x. Take a 3x out of all of them. What are you left with? 2x squared plus x minus 10. Once you've taken out that greatest common factor, you should be looking at that inside part and trying to factor it. I'm going to use the guess and check technique. In other words, I'm going to think about my two factors. I'm going to note that my first factor, one of my factors has to have first term 2x, the other one has to have first term x in order to give me that 2x squared. The numbers I put here have to multiply to negative 10. Negative 10 and 1, 1 and negative 10, 5 and negative 2, negative 2. And I want the middle and the outer to give me positive 1. So I'm going to mess around with that. I'm going to end up figuring out that putting a plus 5 here and a minus 2 here gives me 5x minus 4x, which is 1x. Going into the question, what's the Q? Well, there's a 3 in front of the x. What's the P? 2. What's the C? 5. Okay. Moving forward here. This question is just asking us, hey, how do you factor this? First thing you should always do, always with factoring, take out a GCF. Both of these have a 3x in common. What are you left with? 4x squared minus 9. When you're looking at this, that's special. It's difference of two squares. 4x squared and 9 are both perfect squares. They can both be written as something squared. Okay? What squared is 4x squared? 2x squared is 4x squared. What squared is 9? 3 squared is 9. Difference, because there's subtraction, of two squares. If you can write your binomial as a difference of two squares, it factors like this. Okay. You got 2x and 3, so you got a 2x plus 3 and a 2x minus 3. Okay. The strategy we used was taking out a GCF and then factor using difference of two squares. Cool. Third question here, which of the following is incorrect? Let's just think about what we know. If you look at this parabola, it's in factor form. It's got an x-intercept at 1, an x-intercept at negative 3, and it opens upside down. X-intercept at 1, that's true, so that's not the answer. X-intercept at negative 3, that's true, so that's not the answer. It opens down, that's true, so that's not the answer. Now I got to check these guys. Y-intercept of 0, 3. How do you find a y-intercept? You plug in 0 for x. Okay, so if I plug in 0 for x here, I get 3. That means my y-intercept is 3. So that is true. Okay? That must mean that it's not the answer. So the thing that's incorrect must be this one. Axis of symmetry is x equals 1. Let's verify that. Well, I know that I have an x-intercept at negative 3 and an x-intercept at 1. I have an x-intercept at negative 3 and an x-intercept at 1. The axis of symmetry is supposed to be right in between those. So it should be at negative 1, not positive 1. Okay. Moving forward here, it's asking me to write a possible function f of x in factored form for this graph. Okay. I hope when you think about that, you're thinking about the fact that each factor is connected to an x-intercept. I have an x-intercept of negative 3, so I have a factor of x plus 3. I have an x-intercept of 1, so I have a factor of x minus 1. I have an x-intercept of 3, so I have a factor of x minus 3. The only thing you have to be careful about here is making sure the end behavior is right. So the function I wrote right now is third degree, but as a positive leading coefficient, so its end behavior would be down, up. And the graph I'm looking at has an end behavior up, down. So the way to change that is to make the make the leading coefficient negative. You could put just a negative out here. You could put a negative 5, a negative 12, a negative 2, whatever, as long as you put a negative leading coefficient out. Moving forward to question 5. Here are 3 forms of a quadratic. Asking us, what do you tell from those forms? Well, vertex form tells you the vertex. That's called vertex form. Factor form, I hope that this idea is becoming clearer and clearer. Each factor tells you an x-intercept. There's a direct connection between factors and x-intercepts. That leaves us with standard form telling us the y-intercept. Remember, standard form of a parabola is y equals ax squared plus bx plus c. If you got a parabola in that form, the c is the y-intercept, so 0, c. That number at the end is the y-intercept. Sixth question here, you got to find the mistake. It's a little bit tricky here. Mistake happens kind of early on. It's right in this line. Okay. When they take that 2 out, they take it out of the x squared, but they don't take it out of the 5x. We should be left with 5 halves x there. So that when we go to find our super secret special number, we do 5 halves divided by 2 is 5 fourths. And then the new number we're supposed to put there should be 5 fourths squared, which is 25 sixteenths. So the new number we should have put there should have been 25 sixteenths because we forgot to take the 2 out of both the 2x squared and the 5x. When you take a 2 out of 5, you're left with 5 halves. Last question here says, which of these situations is impossible? This is the one that's impossible, and the way to think about this is relating to end behavior. So third degree polynomials, there's 2 possibilities for the end behavior. Since they're odd degree, the end behavior could either be down, up, or up, down. Let's talk about down, up first. My graph's end behavior is down, up. Well, then somehow those arrows have to get connected. It's kind of like continuity. There's no way I can connect those arrows without crossing the axis at least once. Okay, it's impossible. If the end behavior is up, down, which is the other possibility for a third degree polynomial, the same idea applies. I start up and I end down. There's no way I can connect those 2 points, those 2 arrows, without going through the x-axis at least. For an even degree polynomial, second degree polynomial, it's totally possible that it has no x-intercepts. Look, end behavior for a parabola can be up, up. It can look like this. No x-intercepts. It's those odd degree polynomials that have to have at least one x. So this is the one that's... All right, thanks for watching. That concludes this video.